This is the fall 2019 Common Exam number 1, and I'm just going to go through all of the questions and explain how to do it. So number 1, find the length of the curve, and they gave this curve, this one right here, as well as the domain 1 to 3. So since it says it asks for the length of the curve, we're going to use the arc length formula, which is the integral from a to b of the square root of 1 plus f prime of x squared dx. And over here you can also write dy over dx squared, that's completely fine. But I'm going to stick with f prime of x squared. And so for these type of questions, I like to do all the work outside. That's how my professor taught me. So y is equal to, let me just rewrite this, x cubed over 3 plus 1 over 2x, y prime, or f prime of x, same thing. So 1/3 times 3x squared plus 1/2 times -1 x to the -2. I'm going to just rewrite this so that 3 cancel out with this 3. So you get, oh my god, wait a second. Whoops. 6. So that cancels out, and that gives us 2. So we're left with 1/2 x to the x squared minus 1/2 x to the -2. And one last thing I'm going to do is that I'm going to factor out, I'll leave that in. No, I'll factor it out. So I'm going to factor out this 1/2 as well. So 1/2 x squared minus x to the -2 power. And this is going to be useful for when I square this value. So the next step is going to be to square this. And so splitting this up like this just makes it a bit easier for us. So we get 1/4 times x to the 4th minus 2 times x squared times x to the -2 plus x to the -4th. And this will cancel out to give us 1, so it's just going to be 2 there. So I'll just rewrite this. 1/4 minus x to the 4th minus 2 plus x to the -4th. And for the last step here, I'm going to plug these right back in, distribute this 1/4 as well. So 1/4 x to the 4th minus 1/2 plus 1/4 x to the -4th. And so this is going to be good for when we add the 1. So y prime squared plus 1 is equal to, and let me just rewrite this one more time, 1/4 x to the 4th minus 1/2 plus 1/4 x to the -4th, and now we're adding 1. And so this 1 is going to obviously go over here, right, because this is the same amount of terms, x to the 0. And what that leaves us with, so this term and this term will remain the same, 1/4 x to the 4th, but this time, rather than writing -1/2, plus 1 gives us positive 1/2. So I'm going to positive 1/2. And then this 1/4 x to the -4th stays the same. And I will refactor it. I know it looks weird that I'm going back and forth, but it just makes it easier per each step. So I'm going to remove that 1/4 one more time. And you'll see why in just a minute. X to the 4th plus 2 plus x to the -4th. And so the whole idea of what I'm doing over here is that I want to find a way to get this and so that it's simplified over here. And the best way to do that, in this case at least, is going to be to factor it so that it's a perfect square. And what we know is that right over here, where am I? Right over here, we see this exact same thing coming from this right here. This right here. But the only difference now is that instead of a minus sign, we're going to have a plus sign, because it's positive 1/2 rather than negative. So writing this out, I'm going to put it all in big brackets. It's going to be 1/2, and 1/2 because you want to square this value as well. So it has to be, it's 1/2. Open parentheses, x squared plus x to the negative 2. And that lines up exactly to what we had right over here, except now that instead of having that negative 1/2, we're going to have, or negative, or minus x to the negative 2, we're going to have a plus there. Okay. And that's obviously going to be squared. Now we can go back to our original equation. I'm just going to rewrite it. L is equal to the integral from, I believe it's 1 to 3, of the square root of 1 plus f prime of x squared dx. And now we have everything that we need right over here from this, which is the same thing as this, the same thing as that, to put in that square root. So let's rewrite this, which is equal to the integral from 1 to 3 of the square root of 1/2 x squared plus x to the negative 2 power, all of this being squared, and under the square root dx. And what those will do, let me put this under 100, is that this square root will cancel out with this squared, leaving us with literally just the original equation. Well, not the original equation, but this value underneath without any exponent. So L is the integral between 1 to 3 of 1/2 times x squared plus x to the negative 2 power dx. And this is going to be our integral setup. And from here, all we need to do is just evaluate. So L is equal to, I'm going to pull out the 1/2, x cubed over 3 minus negative, 1 over x. Evaluated between 1 and 3. L is equal to 1/2, and then right here is just plug in and solve. 3 cubed over 3 minus 1/3 minus 1 over 3 minus 1. L is equal to 1/2. That's going to be equal to 9 minus 1/3. So I'll put that into 2/3, merging these two together. It's 2/3 plus 1. So it's 10. I'll just reset and write 10 minus 2/3. L is equal to, so 30 minus 2 is 28. 28 over 3. 1/2. That can cancel out with this, give us 14. So L is equal to 14 over 3 units. Number 2. And I'm just going to quickly get a screenshot of this, so that way you're able to see it right on. Okay. millimeter little. A spring has a natural length of 1 meter. A force of 10 newtons stretches the spring to 1.1 meters, i.e. 1/10 meter beyond its natural length. How much work is done when compressing the spring from 1 meter to 0.5 meter? Okay. So they mention a spring. Okay, maybe I should use a little less thick. So they mention a spring here, which is pretty important because that tells us what formula we want to use. So the Hooke's law is F is equal to Kx, where K is the spring constant, and X is going to be our displacement. Okay. And they don't provide us with this K value over here, which means that using this information we have to find that first. So, but they give us the information that so we can solve this, right? Using this formula, 10 newtons is equal to K times 1/10 meters. And they tell us 1.1 meters here, but it's the natural length is 1 meter, so we have to do 1.1 minus 1.1. Over here they say 1/10 beyond its natural length, so in this question they give us that point, but most of the time they don't do that. Okay, so K is equal to 100 newtons over meters. The unit probably isn't important at this step, but I guess write it down anyways. Okay, and now we're looking for work when compressing the spring from 1 meter to 0.5 meters. So the formula for work is the integral from A to B of f of x dx. That's the most rudimentary formula. And f is equal to kx, as I wrote before. So w is equal to the integral from 0 to 0.5. And the reason we put 0 and 0.5 is because 1 meter is the starting point. So if I have like a little spring there, this point right here is going to be our 0. And any movement in either direction is going to be the displacement in either direction from 0 to that point. In this case, we want to compress the spring to 0.5 meter. So we move it back 0.5 meters. So it's from 0 to 0.5. And it's always going to be a positive number because you can't have a negative work. Okay, and so we want to put f of x, which is k of x dx. We just solve for k, which is 100 newtons. So w is equal to integral from 0 to 0.5 of 100 x dx. W is equal to, and then we could just solve for this, which is 50 x squared evaluated between 0.5 and, 0 to 0.5. W is equal to, and we don't need to worry about that 0. We do need to worry obviously about the 0.5. 0.5 squared is 0.25, so 50 multiplied by 0.25. I'll just write minus 0 just to say, okay, we don't need to worry about that 0. And so 50 over 0.25. I don't think we could simplify this. It's the same thing as putting 50 over 4. Oh, we could. 50 over 4. It's the same thing as 25 over 2. And the units here are important. So it's going to be newtons times meters. Yeah, make sure you don't forget units. 25 over 2, newton meters. So yeah, that's number 2. Pretty straightforward problem. This is 2 steps. Make sure you don't forget that x value. when you put in the integral. So that might mess some people up. And I threw it all the way up here. Let's bring that down. All the way down. Number 3. The region between the curve y is equal to e to the x, y is equal to 0, x is equal to 0, and x is equal to 1 is revolved about the x-axis to generate a solid. Okay. So just a quick little graph. You have e to the x. I'll use a different color. You have e to the x, something like that. Y is equal to 0, which is just like that. Actually, let me just redraw this real quick. No, it's like that, yeah. It's not touching the x-axis. Because this is at 0, 1. X is equal to 0, okay, right over here, and x is equal to 1, which I will say somewhere right here. And that's revolved around the x-axis, so let me take a different color, like yellow. No. What am I doing? Around the x-axis to generate a solid. Okay, so we have this shaded region over here, which is rotated around the x-axis to form a solid. Okay, and we have to find the void. So there's a couple of different ones. I think basically all of the methods work. So you can use disc, not cross-section, but you can use disc, washer, or cylindrical shell. I'm going to use the disc method just because it's the easiest one. And in this case, there's no gap, so we don't need to worry about anything like that. For washer or cylindrical shell, we will. But for this one, it's straightforward. So let's put disc method. V is equal to pi, the integral from a to b of r of x squared, r of x squared dx. R of x, take another color, represents the distance from the graph to the axis of rotation. And the axis of rotation in this case is the x-axis. And since we're rotating around the x-axis, we are going to be using dx. So the only case where it's the opposite, whereas before it's not, is going to be for cylindrical shell. But over here, since it's this method, we're fine. So v is equal to pi, the integral from 0 to 1 of, and I'm just going to write y squared, because that's what it is, right? If this point is x, y, the distance from here to here is y. But obviously, if you couldn't already tell, you can't put y here because that is not allowed because we're using dx. So we want everything to be in terms of x. So what we're going to do is rewrite this pi from the integral from pi times the integral from 0 to 1. And instead of y, we're going to plug in what y was. E to the x. E to the x squared dx. And then we can write that again, pi, the integral from 0 to 1 of e to the 2x dx. And now from here we can just solve. So v is equal to pi e to the 2x, so that stays the same, but you divide by 2, and then it's evaluated between 1 and 0. Over here, please be careful. Don't exclude the 0 here. This 0 does count, because e to the 0 power is going to equal 1. Right, so you're going to have something there. So let's rewrite this one more time. V is equal to pi e squared over 2 minus 1/2. And I don't think there's a lot we could do from here. V is equal to e squared minus 1 over 2 pi. And that's going to be your answer. And it's in units cubed. And so that's the answer for number 3. Number 4. length of cable hangs from the edge of a tall building. How much work will it take to pull the rope to the top of the building if it weighs 2 pounds per foot? Okay, you could make a little drawing if you want. I'll draw a little person. It's going to be pulling that rope. Give you like some gray. So the hands in the rope. And at the bottom of the rope, see some blue. Oh, there's nothing on. Okay, so it's just the cable. There's no bucket or mass that's hanging off of it. You just have this person that's pulling a cable, and you want to calculate how much work they're doing. So the work of the cable is equal to the integral of f dx, from a to b obviously, of f of x dx. Whoops. F of x dx. And in problems like these, your f is going to be the weight. Where's the weight? Oh, right here. The weight. So in this case, f is equal to 2 pounds per foot. Actually, no, we're missing something here. We need to multiply this by the remaining distance, dx. So there's 2 components for this, right? Because the reason for this is that the weight that the person is going to have to carry when the string is all the way at the bottom is going to be a lot because you have all the string there. But as they start pulling up, there's going to be less work required. Like if the string's only over here, whereas before it was over here, you're only going to need to carry this much, right? So that's what the remaining distance is for. So we need to calculate for that as well. So the work of the cable is equal to the integral from 0 to 40, right? Because that's the length that you're going to be pulling, of 2 times the remaining distance, which is 40 minus y dy. Oh yeah, this is almost always going to be in terms of y. C and D dy. Right, and so you have this equation, and all you have to do now is solve. So I'm going to quickly just pull the 2 out, 0 to 40, of 40 minus y dy, and now I'm going to solve. So WC, the work due to the cable, is equal to 2 times 40y minus y squared over 2. And that's going to be equal to 2 times 40 times 40, which is 400. Oh, actually, I think I forgot to write this down. Okay. Hold on. Yeah. And this is going to be between 40 and 0. If you plug in 0 for this case, it's going to be equal to 0 and 0, so you don't need to worry about that. You just need to worry about 40. So it's equal to 2 times 400, right? Because we're going to plug in 40 for y. Now, what am I saying? 400. It's going to be 1600 minus 1600 divided by 2. Which is the same thing as writing 1600 divided by 2 for the whole thing. But this is going to be 800. So you're going to have 2 times 800. So the work of the cable is 2 times 800, which is 1600. And now you need the units, which is pounds times feet. And that's the answer for number 4. Hopefully that was pretty good. Number 5, which I'm putting on right now. Okay, so use the shell method to find the volume of a solid generated by revolving the region bounded by y is equal to the x to the 4th and y is equal to ax about the y-axis. Okay, so they tell us right off the bat, use the shell method. Okay, so we can't use washer, and we can't use disk. And I don't think you could use a cross-section anyways in this case, but if you could, you can't use it either. You have to use the shell method. Okay, so they give x to the fourth and 8x. So I'm going to draw 8x first, which is a simple line. And let's say 4x will look something like that. But it'll look really complicated. Hold on, like something like that. Right, it'll go up, it'll go down. No, it won't go down. It'll never go down. It'll be like that. Okay, and this gives us our shaded region right over there. Pretty straightforward. And then tells us right off the bat to use the shell methods. So the shell method formula, v is equal to 2 pi, the integral from, and this is about the y-axis, which means that in this case we're going to be using the x dx, because for the shell method it's always going to be the opposite of what the axis of rotation is. So if it's going to be parallel to the y-axis, you're going to use dx, and if it's going to be parallel to the x-axis, you're going to use dy. So in this case, we're going to do dx. So the integral from a to b of r of x, h of x, dx. Pretty straightforward. What I like to do here is I like to confirm what r of x is and what h of x is outside, and then I plug it in afterward. So let me go ahead and do that. So I will start with h of x. H of x represents the height parallel to the axis of rotation. So if this is the axis of rotation, this right here is going to be your h of x, right? And so the best way to do it is to figure out what is this gap. And that gap can be signified by the top function minus the bottom function. So what is the top function? Y is equal to 8 of x. And the bottom is going to be y is equal to x to the fourth. So h of x is equal to 8x minus x to the fourth. And that's it. R of x is the distance between, I'll use a different shade of green, between the axis of rotation and the graph. And so, all you need to do is put in x. And that's it. Why? Because the distance from here to here is simply x. That's the definition of what x is. Right? And so, all we need to put there is x. So v is equal to 2 pi, the integral from a to b, and I think I'm accidentally going too far to the left here, but sorry, of x times 8x minus x to the fourth dx. We can distribute that x, so v is equal to 2 pi, the integral from, and I'll put a to b in. Actually, no, we don't know what a to b is yet, so we have to solve that as well. We know a is 0, right? Because when you plug in 0 for both of these, they're going to be 0. But we don't know what the second function, this point right here, is, so we have to solve for that. The best way to do this is set them equal to each other. X to the fourth is equal to 8x. Bring them all to one side. X to the fourth minus 8x is equal to 0. Factor on x minus x cubed minus 8 is equal to 0. So you get x is equal to 0. That's straightforward. And I'm not liking what I'm seeing here. X is equal to 2. Plus minus 2. No. Minus 2. If you plug in 2 here, you're going to get 16. If you plug in 2 here, you're going to get 16. Okay, yeah, so it's 2. Not negative 2. Don't know why that's there. I think it's plus minus 2. No, can't be minus 2, though. It's going to be 2. Okay. So from 0 to 2, and if you don't know how to factor, apparently like how I don't, you can just plug it in. It's going to be a close number. So yeah, in this case, x is equal to 2 is going to be that point over there. And we're just going to distribute this x inside. So you have 8x squared minus x to the 5th dx. And then we're just going to solve 2 pi 8x cubed over 3 minus x to the 6 divided by 6. Evaluate between 0 and 2. V is equal to 2 pi. If you plug in 0 to any of this, it's going to be 0. So we don't need to worry about that. So 8 times 2 cubed over 3 minus 2 to the 6th power divided by 6 minus 0. V is equal to 2 pi. Whoops. 8 cubed is 8. Multiplied by 8 is 64. Divided by 3 minus, let's see, 2, 4, 8, 16, 32, 64. 64 over 6. Okay. And so this is basically just 64 over 6. That's 2 pi. 2 pi 64 over 6. This can cancel out with that, so you get 64 over 3. I don't even know if 64 is divisible by 3. Hold on. 2 minus 6. No, it's not. It's not divisible, guys. Okay, and so you get the final answer. V is equal to 64 pi over 3 units cubed. And there's your answer for, I don't remember what number this is. Number 5. This is your answer for number 5. All right, let me move this a little bit more centered, I guess. Number 6, the region between the curves y is equal to the square root of x, y is equal to 0, and x is equal to 4 is revolved around the line y is equal to -1 to generate a solid. Find its volume. Okay, so I'm going to draw my graph again. Y is equal to square root of x, so that looks like that. By the way, if you don't know this, I recommend you look at your parent functions. That's pretty important because it will help you immensely. Y is equal to 0, which is that area over here, and x is equal to 4, which is some area right around here. Is revolved around about the line y is equal to -1. So that's over here, behind everything that's going on. So we know the shaded region is right over here, because that's what everything is bounding. Okay, and so now, let me use my yellow. Our axis of rotation is going to be over here. We can either use cylindrical shell method or the washer method. And I think just earlier we just did cylindrical shell, so I'm going to go with washer. Although cylindrical shell might be a bit easier for you, it doesn't really matter. You can't use the disk method because there's a gap right over here. So you can only use the disk method if it was completely stuck on. So like example, if it was x is equal to 4, was the axis of rotation, only then could we use the disk method, or like the x-axis. But here in this case, we cannot use disk. And obviously we can't use the cross-section method. Okay, so let's write down our formula. V is equal to, and this is going to be washer. Let me write that down. Washer. V is equal to pi, the integral from C to D, right? Since this is parallel to the y-axis, we're going to be using dy. So C to D of r of x squared minus little r of x squared dx. This represents the total distance, and this represents the gap. Right, pretty straightforward stuff. So let's start plugging in values. V is equal to pi, the integral from, and that's pretty simple, right? It starts at 0, and they give us x is equal to 4 as the end, right? So it's going to be 0 to 4. No, hold on. Mistake. It's dy. Right, so what we have to do is that we have to find out what this point is on the, let me change this. Actually, let me use this one. On the y-axis, which is 2, because you just plug in 4 into x, right, and you get 2. So this is y is equal to 2. Y is equal to 2. So it's from 0 to 2, not 0 to 4. And then we just go with r of x. R of x is going to be the full thing, which I guess is just 2 to 0, right? So it's 2 squared. 2 squared minus, and then little r, which is the gap, is going to be 2 minus y. Because this distance is y, and we want this distance, and this whole thing is 4. So you want to take the whole thing minus this smaller part, or this one part, to get the second part, right? So it's going to be 2 minus y. 2 minus y, and that's also squared dy. Why do I have everything in dx? It's supposed to everything dy. So let's simplify this. Pi, the integral from 0 to 2 of 4 minus 4 plus 2y minus y squared dy. And look at that. These 4's cancel out. V is equal to pi, the integral from 0 to 2 of 2y minus y squared dy. So let's do the integral. So you get y squared, and that 2 will cancel out with the divide by 2, minus y cubed over 3. Evaluate between 2 and 0. V is equal to pi, and 0 plugged in is going to be 0. You're going to get 4 minus 8 over 3. So it's the same thing as pi 12 minus 8 over 3. So V is equal to 4 pi over 3 units cubed. That's that. Yeah, so personally, I probably would have gone with the shell method. It's just a little bit easier. As long as you remember that the sign is flipped. Here it's not so much that. But I guess they're both good to use. Number 7. Find the area of the surface generated by revolving the curve y is equal to the square root of 4x minus x squared. For 0 is less than or equal to x, which is less than or equal to 3, about the x-axis. Okay, so this is the area of a surface. This is going to be your surface area equation. So area is equal to 2 pi, the integral from a to b of f of x times 1 plus f prime of x squared dx. So this right here is your arc length formula that you may remember, which you should hopefully remember before their exam. And this part right here just comes from the, I believe, the circumference of a circle. 2 pi r. Yeah, I think so. But you don't need to worry about that. What you do need to worry about is memorizing this formula as it is, right? And so we're going to do the same steps as we did before. So I'm going to do the work over here outside and then plug it right back in. So f prime of x, or y prime, whatever you want to use, is equal to 1/2 times 4x negative x squared to the negative 1/2 times, and then we plug in 4 minus 2x. I'm going to rewrite that so I can cancel out the 2. So you get 2 minus x over the square root of 4x minus x squared. Whoops. 4x minus x squared. Now I'm going to take this value and square it, so f prime of x squared. And so the top will be 4 minus 4x minus x squared. No, plus x squared over the square root of 4. No square root now, because the square root will cancel out the squared. 4x minus x squared. Now we're going to add the 1, f prime of x squared plus 1 is equal to, let's rewrite this same values again, plus x squared over 4x minus x squared. And now we're going to add 1, but instead of writing 1, I'm going to use this denominator at the top and the bottom. So 4x minus x squared over 4x minus x squared. And this is still 1 because this and this will cancel out. That would give you the same thing as adding 1. So this is still the same thing. But what this does do for us is that it cancels out all these factors. So all we're left with is 4 over 4x minus x squared. So we literally just removed most of the equation by doing this, right? So I guess this is a fun little hack. And that's everything that goes inside the square root. So let's rewrite our equation. A is equal to 2 pi, the integral from, I think it was 0 to 3, f of x. So we need to rewrite this. What was it? Square root of 4x minus x squared, 4x minus x squared, times this big square root of 4 over 4x minus x squared dx. And so, actually, I'll erase this big square root because we can distribute the square root inside. And just like that, we can cancel out these two. So all we're left with, area, is equal to 2 pi, the integral from 0 to 3 of 2 dx. That's it. That looks pretty easy. In fact, I'm going to take out that 2 as well. So area is equal to 4 pi of 3 to 0 of dx. That's it. Oh, and it's 1 dx, by the way. It's not just 0. Please don't assume it's 0. It's 1. A. Now let's evaluate. A is equal to 4 pi of x evaluated between 3 and 0. So area is equal to 12 pi units squared. Because obviously you don't need to worry about that 0. So you just plug in 3. 3 times 4 is 12 times pi. 12 pi. And that was pretty easy. Make sure, like, usually for these area problems as well as for the arc length problems, you're usually going to have something that you can abuse. So, like, somewhere you can simplify. If you don't, you're most likely doing something wrong. So do please be wary of that. Do be wary of that. All right, last question, I think. Yeah, last question. The base of a solid is the region bounded by the curves y is equal to 2x y is equal to 4, and x is equal to 0. The cross-sections perpendicular to the x-axis are squares, whose bases run between the curve y is equal to 2x and y is equal to 4. Find the volume of the solid. Okay. So let's do a little diagram. Oops. Give me my black. Now let's use the red. We got y is equal to 2x, which is just a line. Y is equal to 4, something like that. And x is equal to 0, which is just your y-axis. And you can see there's a little shape that comes up in the middle, which is what we're going to worry about. And this time, we're going to be using the cross-sections formula. The cross-sections perpendicular to the x-axis are squares. And since they give us the x-axis, it's not rotating around the x-axis, but they give us the x-axis. It's probably going to be useful. Whose bases run between the curves y is equal to 2x and y is equal to 4. Okay. Well, it's perpendicular, so it's going to look, the base of the square is going to be like that, and then it's going to come upward at the same height. And so like over here, for example, there's another one. I'm not making these very good looking. Nah. I need to demonstrate. Hold on. So like that. Hopefully that gives us somewhat of a good idea of what these look like. Right, and the base, this part is really important. The base runs between the curves y is equal to 2x and y is equal to 4. So v is equal to the integral from c to d of a of x dx. Actually, no. I would say this is a to b. Okay, so I'm going to make a guess saying it's a to b, and it's going to be in terms of x. Why? Because it cuts off over here, so I want to find the distance and the use between there. But yeah, and they also tells perpendicular to the x-axis, so that should hopefully be the giveaway. So v is equal to, for the integral from a to b of a of x dx, I'm going to rewrite a of x down here because that's what I want to use. And we're told that it's squares. So the area of a squared side, so I'm just going to write s squared. And the base of it, the base of this square is this difference over here. Let me use a little different color, darker green. So you can see it. This part right here is the base, is the difference between this top function, y is equal to 4, and this bottom function, y is equal to 2x. So let's write that 4 minus 2x squared. And that's what a of x is. So let's rewrite that a of x is equal to, and we can rewrite 16 minus, what is that, 16x minus 4x squared plus 4x squared. That's good. Let's factor out a 4 just to make our lives a bit easier. 4, and then you have 4 minus 4x minus plus x squared. And that just helps us out. with the integral. So v is equal to 4, the integral from a to b, which in this case is from 0 to 2, right? Because that's what this point is. That's x is equal to 2. And we know this because we could set 2x is equal to 4. And all you divide by 2, x is equal to 2. So you get 0 to 2, 4 minus 4x plus x squared dx. V is equal to 4. And then let's just solve. Got 4x minus 2x squared plus x cubed over 3. Evaluated between 2 and 0. So v is equal to 4 times 2 times 4 is 8 minus 2 squared times 2, which is also 8. Oh, did you look at that? That and that will cancel. Plus 2 cubed, which is 8 again, over 3. So 8 over 3. So v is equal to, what was that, 32? Over 3 units cubed. And that's the last question. Luckily in this common exam, there was no hyperbolic questions or 8.1 questions. Oh my god. 8.1 questions. You do need to know arc length, all of the volume formulas, and all of the work formulas, and area for this exam. So everything here will be on the exam, almost 100%. To study, all the best.